Hi everyone, Senan this side, and in this video we are going to see how to do this Geeks for Geeks daily problem, which is delete alternate nodes. Given a single linked list, delete all alternate nodes of the list, that is delete all the nodes present in even positions. So indexing starts from 1 and not 0. So the even positions are the second node and the fourth node and so on. And in this we have to delete these red nodes. So how do we do that? First of all, to delete this red node, what I have to do is to go a step before that, like the previous node. So to delete this node 2, I need to be at node 1. To delete this node 4, I need to be at node 3. So let's say if I am at node 1, what I do is I change this link and I point this to point 1, and what I do is I delete this node. In the next iteration, I'll be at 3. What I'll do, I'll reassign this link from 3 to 4 to 3 to 5 and then delete this 4 and keep on doing this till the time I either reach the end or I reach a null node. In this case, when you are at 99, you delete this 59 and reassign the link from 99 to 42. At 42, you change this link from 42 to 20, 42 to null, which is 20 is next. So 42 to null, and then delete this 20. And in the end, what you are left with is 99, and that goes to 40. A couple of things you need to know is that the first node is always intact, right? And the number of nodes is 1 to 10 to the power 5, and the data is between 1 to 1000. So let's do the same what I said. I'll just implement this in code and let's see what happens. So the base case, what is the base case? If the node is null, which is not the case in this one because we know that the number of nodes is greater than equal to 1, but let's say if head is null or heads next is null, that means we only have a single node. In that case, what I do is I just return. There is nothing to delete. Now after this, I know when I'm performing these lines of code, I know my linked list has at least 2 nodes. So what I'll do is while temp, I'll take this temp which is equal to this head currently, and from this temp I'll delete the next one and I'll reassign the link. So while temp is not equal to null and temp's next is also not equal to null, right? This is because let's say if you have odd number of elements, if you are at the last node, so temp is not null but temp's next is null. So we don't want to delete any node after the last node. So that is why we have two possible checks. So at least I should have a node, I should be at a node which is temp, and I should have a next node that I need to delete. So what I do is I check the node, I store the node which I have to delete. For this case, when I'm at 1, when temp is 1, I store this node 2 in this to delete variable. Now what I do is temp's next is I reassign the links, right? So temp's next is temp's next, that is 1 is now assigned to 3. Now I delete this node 2, and then what I do is I say temp is equal to temp's next. So now from 1 I go on to this 3. So now I'm at 3 and 3's, and being at 3 now I can delete 4 and so on. So that is the idea, and you do this while this is true, while this condition is true, and in the end you will have all the nodes which are at odd positions. So what is the space complexity? Clearly the space complexity is constant because I only have constant number of variables to perform this whole operation. And next is what is the time complexity? So the time complexity is big O of n because we are traversing the list, right? Since we are traversing the list, this is of the order big O of n, and the space complexity is big O of 1. So we are following this vectored time and space complexity. Okay, so yeah, before I end this video, I just want you guys to know that the whole PDF solution of this particular problem is provided in the description given below. Be sure to check that out, and thanks for watching, and I'll see you in the next video.